In this problem, we try to calculate the indefinite integral for this fraction here. Give it a try before proceeding to the answer. For this sort of expression, a common technique is integral by parts. So that is, if you have function u dv, the integral would be uv minus integral of v du. Now, the key here is to figure out how to split this expression into u and v. Alright, so let's go. So we try to use integral by parts. Now, the key here is to figure out which is u, which is dv from this expression here. One thing you notice that for this term here, there is x squared and there is x dx. The derivative of this term is x dx. So let t equal 1 plus x squared, then dt would equal 2x dx. So the expression here, x log x and dx over 1 plus x squared can be rewritten as t squared and then log x, and then x dx would be half of dt. So there is a factor of half here, right? Half, and then there's dt. So we need u dv, right? So which means in this case that would be your u, and we need to turn this to dv. So what derivative would give you t squared? Let's remind you that 1 over t derivative, if the variable is t, is going to be negative t squared. So in other words, what we have is u would equal log x. And what is dv here? This part you can plug in. That is 1 over. Okay, what is v? Notice that this is a dv, so v would be here. There's a factor of 1/2 here. So v would be 1/2 of, there is also, this is positive here, and this is negative sign here. So there is a negative sign, negative, and then 1 over t, which is 1 plus x squared. Or we can rewrite it as negative 2 1 plus x squared. Let's copy the whole thing here, right? Alright, let's call this integral to be I, yeah, by the integration by parts. So I would equal uv, which is log x, and v would be negative over 2 1 plus x squared, and then minus the integral of v. V here, of course, is negative. You have a negative sign, minus, that would be positive, right? And then 1 over 2 1 plus x squared, and then you have du. We know that u here is logarithm here, so du would be 1 over x. So we have 1 over x, so we have x here as bottom, and then this du would be equal that 1 over x dx. This is term that we know. Work on this part. In the denominator, the factor of two terms, you would resort to what is called fraction decomposition. It would be easier if you can have separate term. So let's do that. So let's copy this term here. So we're going to do what is called fraction decomposition. So assume that's equal a over x. A is a constant that we don't know, and that would be 1 plus x squared. Since this is quadratic in the bottom, so here you have linear term, that is bx plus, let's say, d, right? We don't use c because c stands for the constant term for indefinite integral here. X 1 over x squared, and then the cross product here would be a plus ax squared, and then the other term would be here, would be bx squared plus dx. You want the whole thing here equal to 1. A equal to 1, and a plus b equal to 0, and d equal to 0, and then b equal negative 1, right? So that you know that is 1 over x, and then b is negative 1, so minus 1 plus x squared and over, that's x. All right, so let's go back to the integral here now. So here we split it into two parts here. Now individual ones would be straightforward. That equal half of d 1 plus x squared. Okay, for these terms here. Now the integral would be for those who pay attention to details. Now for the integration of 1 over x, the formula here is logarithm of absolute value of x. But in our case, since the original integrand, we have log x in here, so we assume x is always positive, so we can get rid of the absolute sign here in our case. Combine similar terms here, we have log x over 2, so let's put them together. That is log x over 2, and for this term that would be 1 minus, and this term here is 1 over 1 plus x squared, and this constant we're going to fold into 1 here. At the end we can say another some constant for the indefinite integral, and the other term is this part. So, and this can simplify it. So that's the final answer to this indefinite integral. Alright, in summary, for the original integral, if we let uv be this assignment, then we can use the integral by parts to evaluate the expression here. Eventually, that's the answer to the problem. Alright, for these and other interesting math problems, please like, share, and subscribe to the channel.